All right, let's dive deep into these probability distributions. I'm going to cover 3 out of the 6 listed probability distributions here. They all are continuous. But the ones that are in bold font, continuous, uniform, normal, and exponential, these are the absolute essentials. Not that the other ones are not important. It's exactly opposite. The other ones are also important. But over time, throughout your program, whenever needed, we are going to get into the other distributions as well. All right. So let's focus on continuous uniform. Well, we had a discrete uniform, right? Well, this is a continuous version of that. In discrete uniform, I had specific values on x-axis, and you had probabilities for each one of them, right? In this one, all the values on x-axis, they are in a range. It's continuous. This is a continuous random variable. All values on x-axis, they are in a range, in this case between a and b, and they all have relative likelihood. All right, relative frequency or relative likelihood. It's uniform. All right, that's exactly what it is. This line right here is the relative likelihood of all of the values between a and b. Well, what is that height? Well, that height is equal to, it should be a number that area under the curve must add up to 1. What is the area under the curve? Area under the curve is going to be equal to this length times this height, right? It must be equal to, multiplication must add up to 1. Well, this length is b minus a. Well, this height must be 1 over b minus a so that the area turns out to be 1. And that's exactly what I have right here. I say x is uniform between a and b if it's probability density function is 1 over b minus a. Well, for all values of x that are between a and b. For other values, well, for the other values, relative likelihood is 0. And that's exactly what I have here. For x values between a and b, that's 1 over b minus a. For other values is 0. Well, what is the average? Roughly speaking, the intuitive way of looking at this is because it's uniform, the average is going to be the middle point. Middle point is going to be a plus b divided by 2. What is the standard deviation? Calculation of that is not that difficult, all right? We are going to go over that hopefully in the class. Well, and this is an example for you. You can go over it yourself. So in the next video, we are going to talk about normal distribution.